Good morning, nerds! Welcome back. This time, we're going to be doing systems of equations with graphing. We're going to be given two linear equations again, but they're not going to provide us with a solution that we need to check. Instead, we're going to have to figure out how to put both of the lines, so dumb, both of the lines on the graph, figure out where the intersection happens, which will be an ordered pair, and then that's that. So here's what the problem looks like. All right, well, here's the same problem on the whiteboard. We have the two linear equations we're given, and it says estimate the solution, and I left space to write our answer, our solution, which is an ordered pair right on the bottom. But we need to do something first. We need to figure out how to put these on a graph. Now, I've always said to you, like, math builds on what you've done before, so if you were a good student last week, this would have really paid off this week, because we're taking problems in standard form and slapping them on a graph. How do we graph the first equation? It's in standard form, and as you learned last week, because you totally did all the work, in standard form, you can really quickly find the x-intercept and y-intercept, and you'll be able to make a graph from that really quickly. How do you do that? Well, we know one value of the x-intercept always. On the x-axis, your y value is 0, so we have a value to plug in, and then we can solve for the x and know where it crosses the x-axis. So, negative 3x plus 3 times 0 equals 9. And what's 3 times 0? It's 0. So it disappears and leaves us with negative 3x equals 9. Now how do you get x by itself? Divide by negative 3. You get x equals negative 3. All right. So we have the x-intercept. Now let's find the y-intercept. We know one of the values of that coordinate, of that ordered pair. For every y-intercept, your x value is 0. So let's plug in 0 for x, solve for y. Negative 3 times 0 plus 3y equals 9. What's negative 3 times 0? 0, so it just disappears. Now I have 3y equals 9. Divide both sides by 3. You get y equals 3. Oh, so that is your two intercepts, and that's the 2 points you need to make the line. Let's find the x and y intercept for this other equation so that you can put that on the graph and find out the intersection. 2x minus 7y equals negative 14. X-intercept, y is going to equal 0 as always. So 2x minus 7 times 0 equals negative 14. Negative 7 times 0, just 0. So 2x equals negative 14. Divide both sides by 2. And you're going to get x equals negative 7. All right. Now let's find the y-intercept. Y-intercept, x is equal to 0. So 2 times 0 just disappears. You have negative 7, y equals negative 14. Same thing, divide by negative 7. Y equals 2. Boom. So now that we have the intercepts, we can create the graphs. The blue line will be the first equation, where we're going to plot our x-intercept at the point negative 3, 0, and our y-intercept at 0, 3. And then we're going to use the other two intercepts for the red line, where we're going to put our x-intercept at negative 7, 0, and our y-intercept at 0, 2. And now that you can see that they intersect, but it's not directly on the corner of a box, so you're going to have to approximate where it is in between. As mentioned before, our answer is going to be an ordered pair. So let's find the x-coordinate to our ordered pair. As you can see, the intersection occurs somewhere between negative 1 and negative 2. So as we look at the answer choices, you can see that the only one, well, there's two options that make sense. Both of them are negative 1 and 2/5, since it's in between negative 1 and negative 2, not larger than. All right, now let's look at our y coordinate. It's somewhere between 1 and 2. And through our answers, you can see that 1 and 3/5 is about what it is. It's about 3/5 of the way between 1 and 2. That leaves us with D as the only choice. that makes sense. So we're going to select it, hit submit, and bam. Well, wait, bam. Love you, miss you.